I welcome you all to our new chapter, that is unpaired t-test or independent t-test, in which we need two different groups. We just have done about the paired t-test, in which we need a same group before and after the intervention. But if you are having two different groups and you need to check is there any difference among these two groups, for that part we have to use what? Independent t-test. Suppose in this table, in this data, we are having this case and control. Suppose one is case, two is control, and I need to find is there any difference among the lab parameters. Remember one thing, pair t-test, unpaired t-test, we have to use to compare the means. Pair t-test we are using before and after the intervention, and we are using unpaired for this data in which we are having two different groups. If you are having more than two groups, then we can go with the ANOVA test, but as such we can go with the unpaired t-test or the independent t-test. Suppose again here we are having 1 and 2, one is case, 2 is control, and in the same data we are having some lab values as well, hemoglobin, HCT, RBC, MCV, and so on. Suppose for the learning purpose, let's take only few parameters. So how to perform independent t-test? Click on analyze, go to compare means, click on third option, that is independent sample t-test. Click on it. Now in the grouping variables, we have to take data that is in the categorical format. We are having what? Case and control group. So I will shift it here, define groups, as you are having group 1 as 1, group 2 as 2. Here we are having what? Case and control 1 and 2. Click on continue. In the test variables, we have to take all the continuous data. For example, here we are taking some lab values. Suppose I am taking HCT, RBC, MCV, and MCH and other parameters as per your interest. Shift over there. No need to go for options and bootstrap. Click on OK. Now here we have the case and control, that is 1 and 2, and we found that mean of 30.54 plus minus 8.80. What about control group? Mean of 28.14 plus minus 7.16. Same we are getting for what? RBC, MCV, MCH, MCHC and other two parameters as well. Now in the table part we have to report what? Mean plus minus ST. So you will take data from the first table. 30.54 plus minus 8.88. For the control group, we are getting what? 28.14 plus minus 7.163. What about the p-value? We will use the second table. Now in this part, we are getting one more test. That is what? A Levine test. Levine test is used for the variance. So what is variance first of all? How much data is spread. If Levine test is significant, that means p-value of less than 0.05, we have to take equal variance not assumed. If Levine test is significant, that means p-value of less than 0.05, take p-value of what? Equal variance not assumed. Suppose your Levine test is not significant, that is what? P-value of more than 0.05, then we are taking p-value of what? Equal variance assumed, right? Now for example, in the first part, it is Levine test, we are taking hematocrit, that is HCT. Levine test is not significant. Why? It is 0.207. That means more than 0.05. So we are taking p-value of what? Equal variance assumed. And what is the p-value? Significant two-tail. That is what? 0.138. Correct? Now let me take one more example. Let's take platelet count. Here we are having what? Levine test of 0.011. That is significant because it is p-value of less than 0.05. If Levine test is significant, we have to take p-value of what? Equal variance not assumed. So we are taking what? 0.045, and you have to report this part only. Now in the table part, we have to report mean plus minus ST from the above table, and the p-value will take from where? From the second table.